Heating the atmosphere. The campfire is burned down to a bed of hot coals, perfect for toasting some marshmallows. You get a stick about a half a meter long, since heat energy from the coals won't let you put your hand any closer. After a minute, the marshmallow is brown and gooey. You pop it in your mouth. Yikes! You didn't wait long enough for it to cool. This story has two intense heat energy experiences that show two different ways energy can move. 1. The heat that you felt from a distance coming up from the coals, and 2. The heat that burned your tongue when you tried to eat the marshmallow. What is heat energy? Objects in motion have energy that's called kinetic energy. The faster something moves, the more kinetic energy it has. Particles are always in motion, vibrating back and forth in solids and moving all over the place in liquids and gases. The amount of kinetic energy in the particles of a material determines its temperature. In hot materials, particles are moving faster, and in cold materials, they are moving more slowly. Conduction. Heat naturally transfers from hotter location to the cooler one. In our story, the heat of the marshmallow transferred to your tongue, a memorable experience that is an example of what happens when heat energy moves from one place to another by direct contact. That kind of energy transfer is called conduction. The faster moving particles of the marshmallow transfer energy to the slower moving particles of your tongue. If the particles of your tongue gain too much kinetic energy, you feel it as pain. At the same time, particles of the marshmallow lose kinetic energy, so the marshmallow cools off. Some other examples of conduction are when you take a hot bath and the heat moves from water to you, or you just jump into a cold lake and the heat moves from your body to the water. Brr! A hot particle with a lot of kinetic energy collides with a cold particle with little kinetic energy. Energy transfers at the point of contact. The cold particle then has more energy and the hot particle has less energy. Radiation. What about the heat that you felt from a distance coming off of the coals in our story? That energy traveled right through the air without any direct contact. That is called radiant energy. It can radiate or travel in rays from sources like hot campfire coals, light bulbs, and the sun. Rays from the sun travel right through the empty space between the earth and the sun. Some of the sun's rays are visible light rays, and some are invisible, such as infrared rays and ultraviolet rays. The sun is a source of radiant energy. Heating the atmosphere. Our atmosphere heats up by the same two kinds of energy transfer we identified in the campfire story: radiation and conduction. Starting with radiation, the visible light rays from the sun pass right through our atmosphere, strike Earth, get absorbed, and heat up the land masses and ocean. These land masses and ocean come in contact with air particles, and voila! Heat energy is transferred to the air by conduction. Infrared rays from the sun are a different story. Many of the infrared rays make it all the way through the atmosphere like visible rays to heat the land masses and the ocean, but some of the infrared rays get absorbed by certain gases in the atmosphere. Gases that can absorb infrared rays are called greenhouse gases. Carbon dioxide and water vapor are both greenhouse gases. They can absorb infrared rays and heat up. The warm land and ocean also radiate heat energy from the infrared rays. This is a very important idea. Greenhouse gases absorb these infrared rays just as they absorb infrared rays from the sun. Greenhouse gases have earned their nickname because of the way they trap heat in the Earth's atmosphere. The greenhouse gases in the atmosphere include water vapor and carbon dioxide, absorb infrared rays, and then radiate the heat energy in any direction, including back toward Earth. This means if an infrared ray was headed away from Earth, perhaps after being radiated from a hot asphalt schoolyard, it has some chance of being absorbed and re-radiated instead of leaving the atmosphere. The more greenhouse gases, the greater this chance. Without any greenhouse gases, Earth would lose a lot more heat to space. Earth's average temperature would be about 33 degrees Celsius colder than it is. Compare this to the moon, which has an average temperature from 120 degrees Celsius to negative 233 degrees Celsius. Because there is no atmosphere at all the heat in the daytime radiates back into space during night. Greenhouse gases cause the Earth to remain at a stable temperature that permits life. Some solar radiation passes through the atmosphere and some gets trapped in the atmosphere by greenhouse gases. This warms the Earth's surface and the atmosphere. Some solar radiation is reflected by clouds. Some radiation is absorbed by the Earth's surface and warms it. Earth warmed by solar energy radiates infrared radiation. Greenhouse gas particles warmed by radiation coming up from the Earth. Air particles warmed by conduction. So the surface of Earth gets heated by both visible light rays and infrared rays through radiation. In addition, greenhouse gas particles in the atmosphere get heated when they absorb infrared rays through radiation, either directly from the sun or from a heated surface on Earth. Radiation won't warm up nitrogen and oxygen particles, which make up most of the atmosphere and are not greenhouse gases. But all the gases in the atmosphere heat up when they come in contact with the heated surfaces of the Earth, and energy transfers through conduction. In addition, the greenhouse gas particles in the atmosphere that were heated by infrared radiation will come in contact with nitrogen and oxygen particles and transfer heat energy to them through conduction. The final piece of the puzzle is convection. Convection involves making masses of air or water, both fluids, at the hottest parts of the Earth's surface. Huge masses of air heat up, expand, get less dense, and rise. This is the beginning of the largest convection cell on Earth. Over the ocean, large amounts of heat and water vapor rise, riding along these giant convection cells. When the air cools, water vapor condenses onto droplets of liquid water, forming clouds or rain. Convection helps distribute heat and water around the planet, generating weather conditions ranging from mild to severe. Greenhouse gases and climate change. The fact that greenhouse gases can help keep Earth warm has implications for humans and other organisms on Earth. If we change the amount of greenhouse gases, can we change the amount of heat in the atmosphere? One of the greenhouse gases humans regularly produce is carbon dioxide. It's a byproduct that is released every time we turn on a gasoline-powered car or burn coal to generate electricity, among other sources. If you imagine all the electricity and gas used by each human in industrialized nations every day and multiply that number by the number of humans, well, you can imagine why the amount of carbon dioxide in the atmosphere is increasing. Scientists have tracked carbon dioxide in the atmosphere since the 1950s, as shown in the graph.